All right, so we're starting with chapter 14 now. This is our first video, our oikos and hazards. So for this week, we'll be doing this and some odds and ends on ecology. So we've got this part broken into a few videos. And so oikos is another term for the Earth, planet, and we're going to look at some of the hazards. And so we'll start with what they call a case study that they mentioned, and that's mercury. And its toxic effects, just to kind of get us the ball rolling on this topic. So if you look at the picture here, this guy over here is an idiot. He's holding liquid mercury, which you should not do. You can absorb through the skin, very toxic. And old school, as a kid, thermometers were made with mercury, and it's a kind of a cool metal. It floats, it breaks into balls, and if you broke a thermometer, and I, as a kid, played with it, that's probably what's wrong with me. One time when I heated a thermometer, and and it just blew. Today they're typically made with alcohol, but there are some still around. So anyway, it is definitely a toxic metal. It's released into the air, it's in the soil, it's in the rocks, in very minute amount. So it's not really all that dangerous per se in that regard, except for obviously then we separate, we use it, we collect it, and then larger amounts like what's in this guy's hand, it can be a problem. And we'll talk about it later, but we actually use it to separate gold from the rock that it's embedded in. And unfortunately, mercury is one that moves into the food chains, the food webs. And so we can see a little picture and some of the places that it comes up from. You can see the burning of coal, actually incinerating trash. Some of these are some of the places that it can get up, and then it comes back into the ground, gets in the groundwater, and so the question is it dangerous? And the answer to that is yes. And you can see on the bottom we got a picture, and I don't really care about the numbers per se, so don't really worry about those. But you can see a food web. This is actually be a food chain where we've got this direct correlation from one to another. And what you're saying is you can see the parts per million keep rising. And these don't have a lot, but these animals eat these, and then as they eat, it accumulates in their body, and then the fish eat the zooplankton, and the lake trout eats the smelt, and then the herring go, and then the eggs are very, very high, and then if something eats the eggs, it can just continue. So definitely a problem. And we are exposed really in two ways. We're exposed by eating the fish or shellfish, which, we're talking lobster and shrimp, things like that. And that's probably 75% of all human exposure. The rest of it is from breathing in and industrial plants, coal burning plants, solid waste incinerators. So that gets up in the air and then we breathe that in. And the greatest risk is brain damage, typically to younger children and fetuses. And so we'll talk about that a little bit later, but definitely a problem. So sushi is popular now, and we're worried about mercury in that. And so as a pregnant woman, you have to be well aware if you go to the market, there's signs backed by the seafood that you should eat very, very little, if any, shellfish or fish during pregnancy. And so, although fish can be good for you, there are toxins hidden. All right, so we want to kind of just define the word risk, which most people know, I suppose, but in science, in our definition, we're talking about health. There are other types. There are business risks, economic risks, but probability of one's health being harmed by a hazard. Injury, disease, death. So we're going to look at risk. And there's two different versions I want you to know. Well, we want to know risk assessment, and then we want to do risk management. So the assessment is we're using statistics, how likely is something to occur. And then management is once we know that, how do we reduce these hazards? And what are we willing to pay for that? And so these are questions that we should be asking, and I think we are asking, but I'm not thinking we're doing it well. I think often it gets kind of hidden. And at the very end of these lectures, we're going to talk about why we make some bad choices. All right, and then the types of hazards, here's a list of them, and we're going to go through some of these, some not so much. Natural hazards or fires and earthquakes, we live in areas so that are, we have fires going on as we speak. There's the whole state is in Oregon under fire. The West is burning as we speak. We're always worried about earthquakes, and you should be, for risk assessment. Do you have your earthquake kit? Have you done the things you need to do? So we're going to talk about, in this lecture, chapter 14 really does biological hazards and chemical hazards. So those are some of the things we'll talk about. We'll touch on the cultural hazards and maybe even at the end life cycles and choices. So I want you to know the 5 different types of hazards. And this one, we're going to talk about the biological hazards, and you might recognize this picture. This is one of the hazards that is around today, and that is the coronavirus. That is the COVID-19, and that is what is changing our world and getting you to watch a video instead of being in class. So we have different types of infectious diseases, and infectious, we want you to know what that means. It means you can catch it. And these can invade the body. So what we have is 2 different types. We have transmissible and non-transmissible. So transmissible is one that can be passed from one person to another. And then non-transmissible is something that you get that you really can't give somebody else. So if you get it, it's something you have, but it's not something you're going to pass. Some things like MS is not contagious. And then we do want you to know the word epidemic and pandemic. So epidemic is an outbreak of an infectious disease, and then a pandemic is one that is worldwide. So COVID-19 is obviously a pandemic, would be an example. But things like Ebola, when we have an Ebola breakout in Africa, that's a localized, so that would be an epidemic. All right, and always we're worried that epidemics can lead to pandemics, and they become very, very scary. All right, antibiotics are not effective against viruses, so viruses can be very deadly, like the coronavirus. Most of them are transmitted by airborne particles, and COVID-19 can be, but that is not its major source. That's why we're trying to get people to wear masks from the droplets. It's not really airborne in the sense that it's floating around, but it is in water droplets when you speak, and it can be left on surfaces that can stay there, and there's some question on how long, depending on the material, but can say 24 48 hours on a particular object. So this current one is pretty scary, and the book talks about HIV, which is a scary one, very deadly. Again, a virus, and hepatitis B, which can affect the liver. And there are vaccines for that, and transmitted by unsafe sex, sharing needles. So this is a bloodborne pathogen. One that pathogen just means causes a disease. And so these 2 would be passed by fluids. And then we have the avian flu, which is one type of flu. There's all kinds of different types of flu. The avian is a bird flu. And this one can be also very dangerous. So influenza, again, is a flu. All right, let's move on. And the problem is antibiotic resistance. We live in a world today, 2 million annual number of US citizens who get infections cannot be treated with the known antibiotics. That should be scary. 22% is linked to food. You've heard of salmonella breakouts, of E. coli breakouts. And so those are things that underprepared food, not cooked long enough. And then unfortunately now 4% of the US hospital patients pick up infections in the hospital, and some of those are pretty nasty. There is a staph infection that's found in hospitals. That's one of the bigger ones. And then they're really worried about things like MRSA, which can be very dangerous. So what we want you to understand is we're stupid. I guess that's the response I have for you. here we're showing you in this picture kind of natural selection at work. And here we have some bacteria. We take our antibiotics and it kills the yellow ones, but the red ones kind of survive. So you can see what happens over generations. And basically over just a few generations, you can see most of them have become resistant. And the problem we have is we overprescribe antibiotics, and then people don't take them properly. They always tell you to finish them. And once you feel better, a lot of people don't. And so what happens is you don't kill them all. And so you end up with this scenario you see in the picture on the left here. And so it's important that you don't not take them all. Do not save it for later, because all you're doing is building a better bacteria. The other problem is they are overprescribed. You know, you can have a viral infection and the doctor will give you antibiotics. And it's typically because they don't know what you have and they just want to shut you up. They want to get you out of the office. They want you to feel better. And so they will hand you these antibiotics, and antibiotics do not work at all on viruses. So not a good idea. And the problem is we haven't had any major new antibiotics developed in recent years because there's no money. Because once they make an antibiotic, they only work for a short period of time. The drug companies are making things for diabetes, and they're looking for things that are lifelong diseases that you're going to have to take medication for many, many years. And so that's where the money is. That's where all their research is going. All right, and then the last thing. What is the best way to prevent infections? Research, obviously, and vaccines, and we're working on a vaccine for COVID. There's my understanding as of today, there are 6 different ones they're working on and different ways they work. They just put a stop to one of them. Somebody became ill, and they're not really saying why they're sick. And they think it's a side effect of the vaccine. It's only one person in thousands, but they need to stop the trial until they figure out what's going on. Very secretive. Last I heard is they think it might be something to do with the spine. And so if we have any hope for COVID and a vaccine, you know, they're talking before the next election. And odds are, if it's done safely and scientifically, that's not going to happen. There's a lot of people that are anti-vaxxers. I'm going to tell you that that's not real smart. We need you hear this term herd immunity. We need a good portion of people to be vaccinated to make things safe. One of the things is autism being linked to vaccines, and there is no evidence that is true. Matter of fact, all the evidence suggests autism is not increased. It is just better understood and it is more reported. So the numbers really haven't changed. It is just the way that we look at people and how it's being reported. So anyway, vaccinations for kids especially are extremely important. Make sure you get on a schedule when you have children. And we just have to reduce. We need to figure out ways of making sure that everybody does their part. You know, we need healthier people. We should stop. Medicine should not be, once you're really sick, we're going to try to help you. We should be spending money on how to prevent illnesses, which is actually cheaper in the long run. You know, we need to be able to everybody has to have food and water, good nutrition. We need to get, again, vaccinations. And we just need to be smarter. We need to stop putting so many hormones in our foods, in chickens and cows and pigs, because that gets passed on to us. And again, it's making some of these really nasty bacteria. And so we will stop the share on this part now that you're totally depressed. And we will stop the recording. You're all going to die. I keep saying that. So you're all going